Hi, welcome to another 4AC tutorial, topic 4. If you recall, topic 4 is about power, 4AC power. So in this question, we are given a circuit with three loads. The first is an inductor, the second is a capacitor, and the third is a purely resistive load. And we are asked to calculate the real power, the reactive power, and the apparent power for each of these elements. Right, there's the inductor, the capacitor, and the resistor. And finally, to determine the total real power of these three loads, the total reactive power of these three loads, and the apparent power of the whole circuit. And we need to find out what's the power factor of this circuit, that is the whole circuit. And then finally, we want to draw the power triangle of the circuit. Well, let's get started. Well, to answer this question, what I've done is to redraw this circuit very quickly for an AC supply and the three load 1, load 2, and load 3 with their respective reactance and resistance. And to better understand the whole thing, I come up with this table. Okay, load 1 is the inductor. Now, in inductor, as we understand, does not have real power. So, inductor has 0 real power. Now, it have a reactive power, and we know it's an inductor, so we can actually calculate the reactive power using this formula, since we already know the voltage V squared upon XL. That's 100, the RMS value. Remember, E, the RMS value is E maximum divided by root 2. That's equals to root 2, 100 divided by root 2. So that's 100. So I have 100 squared divided by 200. That gives me 50 VAR. Okay, VAR. Similarly, since this 0, this is 50 VAR, the apparent power will be 50 VA. Second load, the capacitor, same thing, there is no real power in the capacitor, so it's 0. And I can calculate Q, the reactive power in the capacitor, using the same formula, but this time I use the reactance of the capacitor. So equals to 100 squared divided by 500. That gives me 20 VAR. And the apparent power in the capacitor is the same as this, so that will be 20 VA. Finally, for load 3 is a resistive load. Therefore, there will be a real power, which is E squared upon R equals to 100 squared upon 100, and that gives me 100 watts. Here I have 0 VAR, and here will be 100 VA. Therefore, the total real power will be just 100 watts. The total reactive power, remember the capacitor inductors, they are all opposite each other, so we have a positive J and a negative J. So the final, it will be just 50 minus 20, that's 30 VAR. And to find S, we use the formula S equals to square root of P squared plus Q squared. That's equals to square root of 100 squared plus 30 squared. And that gives us a value of 104.4 VA. Okay, so answers are here and the individual. Alright, so that answers part 1 and part 2 of this question. To understand to calculate the power factor, I need to find the angle that is formed by these three. So actually, I could just easily draw the power triangle. Power triangle is 100 watts. P is 100 watts. Q is positive, so I should draw this way, 30 VAR. And the apparent power S is 104.4 VA with this angle theta. So angle theta for cosine is just P over S. So that's equals to 100 divided by 104.4. So that is equals to 0.96. Lagging because it's more inductive. Now if I want to know the angle, I could just do a cosine inverse, right? Therefore the angle theta is cosine inverse of 0.96. Actually this is not required, but I just want to calculate it to complete the power triangle. That is just 16.7 degrees. So this is 16.7 degrees power triangle. And this is the answer for 3. Right? So that's all for this tutorial question.